Welcome to the third in the series of videos where we review the bio-decontamination process of VHP applied in GMP manufacturing environments. Today we continue by getting insights from our subject matter expert, James Drinkwater, Head of GMP Compliance at Franzil. James, VHP is commonly used for material transfer. What are the key points to ensure GMP compliance?
Yes, there are increasingly materials coming into clean rooms that are pre-packaged and pre-sterilised that need surface bio-decontamination that are difficult to manually disinfect. So the application of VHP is ideal for such surfaces, for this bioburden reduction as you enter through into clean rooms. And basically at Franzil we have certain what we call rapid decon stations that enable to decontaminate these materials inside a controlled space created with grade A environments to enable us to take those materials safely to a filling line. At the same time as the cycle, we decontaminate rapid decon ports. These are sort of RTP port canisters that enable that safe transfer for that septic transfer. The monitoring of that particular system maintains grade A conditions, that RDS system. So we can use that as an aseptic hold for that use. So we can hold for batch or a campaign the materials and use them when required.
Thank you, James, for outlining those key GMP considerations for material transfer using VHP. Let us now turn to the topic of process monitoring. How is the validity of a bio-decontamination cycle confirmed through process monitoring?
Yes, when the original cycle was developed and qualified for sporicidal efficacy, there were a number of key process variables and control parameters that were characterized and confirmed as a valid cycle. The challenges then were by biological indicators and enzymatic indicators to confirm that efficacy. But once that cycle is qualified and in use, we now need to consider process monitoring and the validity of the cycle that's run on that day to the comparability to the original cycle. And this is where process monitoring kicks in. Now, the regulatory authorities have actually increased the observations around not applying effective process monitoring, now introduced into Annex 1 as a requirement. And this needs to be understood how you characterize this cycle with process monitoring. Now, what we do at Franzil, we have for validity a whole series of checks that are made for the SOPs, load pattern compliance, glove extenders installed correctly, and they're in the right position. But the parameters for control come from the gas concentration digital profile. And this digital profile in Franzil is analysed first by applying design space over certain key phases that within that design space we can appoint what we term as measuring points to characterise that that cycle run on this day was comparable with the cycle that was originally qualified. So we're using the system software to do that interrogation of the data and report on the batch reports the compliance. And this is something that is really ahead of the game at Franzil in this Annex 1 requirement for process monitoring. And as we see the regulatory observations increase on this, we think we're well positioned to cover those observations. Thank you.
Thank you, James, for explaining how process monitoring supports cycle validity. Finally, for today, let us talk about efficiency. What cycle times can be optimized for septic filling and how is this optimization achieved?
A typical VHP cycle time for a filling line these days is around 2 hours with an aeration endpoint of 1 ppm. Excepting if you went down to 0.1 ppm, this may be longer. What we consider here is that we need to actually optimize the cycle time with technical integrations. And these are optimized by the use of PTFE HEPA filters, which are hydrophobic, direct injection technology, which gets that rapid rise to process lethal conditions, and catalyst systems that are integrated with, which are carbon impregnated cloth. And these all complement reducing the amount of peroxide that we use in the system. In difference to other on the market, Franzil Bio-Decontamination system has 4 injection rates, really to optimize the injection dosing of peroxide into the environment. The less you put in, the less time to get out. You only need microcondensation in the terms of 6 microns deposition on critical surfaces to achieve 6-log sporicidal efficacy. This is a minute, invisible amount. It's not heavy microcondensation. So we at Franzil have these optimizations to produce these very fast cycle times. We're often 20% shorter in cycle times than the rest of the available on the market, and sometimes even shorter than that. But it's all about the technical integration. Thank you.
Thank you, James. Don't forget to join us for the next episode, where we'll discuss strategies for managing BI quality variances, including work BIs, and review the final takeaways for this video series. See you next time.